According to the National Electrical Code, specifically Article 250.112a, the equipment grounding conductor, often referred to as the EGC, of the branch circuit is generally considered a suitable grounding path for bonding metal components of a jacuzzi to copper water pipes. This article emphasizes that bonding jumpers are essential for electrically connecting all metallic parts and equipment to the grounding electrode system. These connections must occur at the service entrance, at each individual building or structure where power is obtained from a separate service, and at the origin of a separately derived system. The equipment grounding conductor effectively acts as a bonding jumper in this scenario. It establishes a link between the metal parts of the jacuzzi and the grounding electrode system located at the service panel. Given this arrangement, it's generally not necessary to install a separate number 8 solid grounding wire running directly from the jacuzzi back to the panel. The equipment grounding conductor within the branch circuit provides the necessary grounding path. Some important considerations include: firstly, the EGC needs to be appropriately sized to handle the ampacity of the branch circuit to ensure its effectiveness and safety. Secondly, the connection between the EGC and the metal parts of the jacuzzi must be both secure and permanent. This ensures a reliable grounding path in all conditions. Thirdly, the jacuzzi should be installed on a dedicated branch circuit. This circuit should always be protected by a ground fault circuit interrupter, also known as a GFCI, to provide enhanced safety against electrical shocks. It's important to understand that the NEC provides minimum safety standards. Local codes or specific installation requirements might have additional or more stringent rules. Always consult local electrical codes and regulations and seek guidance from a qualified electrician when installing or modifying electrical systems, including jacuzzi installations. The equipment grounding conductor plays a crucial role in electrical safety. Its primary function is to provide a low impedance path for fault current to return to the source. This low impedance path allows the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and interrupt the circuit in the event of a ground fault. Without an effective equipment grounding conductor, fault current could flow through unintended paths such as metal enclosures or water pipes, creating a shock hazard. The purpose of bonding is to connect all metal parts that are likely to become energized during a fault. This includes metal enclosures, metal piping systems, and other conductive components. By bonding these parts together, they are all brought to the same electrical potential. This minimizes the voltage difference between them, reducing the risk of electric shock. The grounding electrode system is a network of interconnected grounding electrodes that are buried in the earth or bonded to metallic water pipes or building steel. This system provides a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current to dissipate. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metallic water pipes that are in direct contact with the earth for at least 10 feet. These electrodes are connected together using grounding conductors, which are typically made of copper or aluminum. The size of the grounding conductor is determined by the size of the service entrance conductors. In addition to the grounding electrode system, the NEC also requires that all metal water piping systems be bonded to the grounding electrode system. This is to prevent the water pipes from becoming energized during a fault. The bonding connection is typically made by connecting a bonding jumper from the water pipe to the grounding electrode system. The size of the bonding jumper is determined by the size of the service entrance conductors. The GFCI is a safety device that is designed to protect people from electric shock. It works by monitoring the current flowing through a circuit and comparing it to the current returning through the same circuit. If there is a difference of more than 5 milliamps, the GFCI will trip and interrupt the circuit. This can happen if someone comes into contact with a live wire or if there is a ground fault in the circuit. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. They are also required for all receptacles that are located within 6 feet of a water source. When installing a jacuzzi, it is important to follow all of the NEC requirements for grounding and bonding. This will help to ensure that the jacuzzi is safe to use and that there is no risk of electric shock. Firstly, make sure that the jacuzzi is installed on a dedicated branch circuit. This means that the jacuzzi should have its own circuit breaker and that it should not share a circuit with any other appliances or equipment. Secondly, the branch circuit should be protected by a GFCI. This will help to protect people from electric shock if there is a ground fault in the circuit. Thirdly, the jacuzzi should be bonded to the grounding electrode system. This can be done by connecting a bonding jumper from the metal parts of the jacuzzi to the grounding electrode system. The size of the bonding jumper is determined by the size of the service entrance conductors. Fourthly, all metal water piping systems should be bonded to the grounding electrode system. This is to prevent the water pipes from becoming energized during a fault. The bonding connection is typically made by connecting a bonding jumper from the water pipe to the grounding electrode system. The size of the bonding jumper is determined by the size of the service entrance conductors. Finally, make sure that all of the electrical connections are made properly and that they are securely fastened. This will help to prevent loose connections which can cause fires or electric shock. When working with electricity, it is always important to take precautions to protect yourself from electric shock. Wear rubber gloves and safety glasses, and make sure that the power is turned off before you start working on any electrical equipment. If you are not comfortable working with electricity, you should hire a qualified electrician to do the work for you. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician to ensure that your jacuzzi is installed safely and in accordance with all applicable codes and regulations. Improper grounding and bonding can create a serious risk of electric shock or fire. Therefore, it is essential to follow all safety precautions and to seek professional help when needed. In addition to the specific requirements for jacuzzi installations, the NEC also contains general requirements for grounding and bonding that apply to all electrical systems. These requirements are designed to protect people and property from electrical hazards. The NEC requires that all electrical systems be grounded to provide a low impedance path for fault current to return to the source. This low impedance path allows the overcurrent protective device to quickly trip and interrupt the circuit in the event of a ground fault. The NEC also requires that all metal parts that are likely to become energized during a fault be bonded together. This includes metal enclosures, metal piping systems, and other conductive components. By bonding these parts together, they are all brought to the same electrical potential, which minimizes the voltage difference between them and reduces the risk of electric shock. The NEC specifies the types and sizes of grounding and bonding conductors that must be used in different applications. The size of the grounding conductor is determined by the size of the service entrance conductors, while the size of the bonding jumper is determined by the size of the circuit conductors. The NEC also specifies the methods for making grounding and bonding connections. These connections must be made in a way that ensures a reliable electrical connection and that can withstand the stresses of normal use. The NEC is a complex document that is constantly being updated to reflect changes in technology and best practices. It is important to stay up to date on the latest requirements in order to ensure that your electrical system is safe and in compliance with all applicable codes and regulations. If you have any questions about grounding and bonding, you should consult with a qualified electrician. They can help you to understand the NEC requirements and to ensure that your electrical system is installed safely and correctly. The equipment, grounding conductor, and bonding are critical components of an electrical system that provide safety against electrical shock hazards. The equipment grounding conductor provides a low impedance path for fault current to return to the source. Bonding connects all metal parts that are likely to become energized during a fault. Bonding brings these parts to the same electrical potential. This minimizes the voltage difference between them, reducing the risk of electric shock. It is always important to consult with a qualified electrician to ensure that your electrical system is installed safely and correctly. When dealing with electrical installations, it's crucial to understand the difference between grounding and bonding, as these terms are often used interchangeably but serve distinct purposes in ensuring electrical safety. Grounding refers to connecting an electrical circuit or equipment to the earth. The main goal of grounding is to provide a low resistance path for fault currents to flow back to the source, typically the electrical panel, in the event of a fault condition. This allows the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and disconnect the circuit, preventing electrical shock hazards and minimizing damage to equipment. The grounding electrode system, which consists of ground rods, ground plates, or metal water pipes, establishes the connection to the earth. Bonding, on the other hand, involves connecting all metallic parts of an electrical system together to create an electrically conductive path. The purpose of bonding is to ensure that all metal components are at the same electrical potential. This minimizes the risk of voltage differences between them, which could lead to electric shock if someone comes into contact with two different metal parts simultaneously. Bonding is achieved by using bonding jumpers, which are conductive wires or straps that connect metal enclosures, conduits, pipes, and other metallic components. In the context of a jacuzzi installation, both grounding and bonding are essential for safety. The equipment grounding conductor, which is part of the branch circuit that supplies power to the jacuzzi, provides the grounding path for fault currents. This conductor connects the metal parts of the jacuzzi to the grounding electrode system at the service panel, ensuring that any fault current will quickly trip the circuit breaker. Bonding is also necessary to connect all metal parts of the jacuzzi, such as the metal frame, pump housing, and any metal piping, to create an equipotential plane. This minimizes the risk of voltage differences between these parts, protecting users from electric shock. While the equipment grounding conductor typically provides a primary grounding path for the jacuzzi, it's important to ensure that all metal parts are properly bonded together to create a comprehensive safety system. In some cases, local codes or specific installation requirements may necessitate additional bonding measures, such as running a separate bonding wire from the jacuzzi to the grounding electrode system. Always consult with a qualified electrician to determine the specific grounding and bonding requirements for your jacuzzi installation. In summary, grounding provides a path for fault currents to flow back to the source, while bonding ensures that all metal parts are at the same electrical potential. Both grounding and bonding are crucial for electrical safety, and it's important to understand the difference between them to ensure that your electrical system is installed correctly and safely. The National Electrical Code Article 250 covers grounding and bonding requirements in detail. It is important to consult this article when installing any electrical equipment, especially in potentially hazardous locations such as bathrooms and swimming pool areas.